What we're going to do today is look at how to use spreadsheets for time value of money problems. And there's really multiple ways to do any time value of money problem. You can brute force it, which means you're going to bring back each one individually or take forward each one individually, each cash flow. You can use formulas such as annuities or perpetuities, growing annuities, etc. Or you can use pre-made spreadsheet formulas. So we're going to do each of these. So here we have $100 each year for 10 years. So that is an annuity, we know that, but we're going to brute force it first just to make sure we all know how to do that. So here we are, we have equals the cash flow divided by 1 plus the required return, and raise that to the number of periods, and I'm going to just put a $sign in here to anchor it down so I can copy this D1 so we always have it linked for the required return, and that's $95 for the first year, which makes sense because you would invest $95 at 5%. In 1 year you would have 100. So let's just check that if we want to. This is going to equal, you know what, we can't check it. That's something different. We'll do that something different in a second. So it's less than $100. It does make sense, trust me on that one. So we're going to copy this down, and Control V, paste them in, and then add them up. We can now add them. We couldn't add them before because they're different years, but now we take the present value, so they're all in year 0, current time period. So we can sum those all up, and we get a number that is $772.17. Okay, so that represents $100 each year at the end of each year for 10 years. And I'll put those all in currency. So there we go. That's how much each one of those is worth. So just for interpretation purposes, the $100 at the end of year 4 is worth $82.27 today. So that's one way to do it. We also realize that this is an annuity, and there is a pre-made Excel formula for that, or spreadsheet formula. This actually is Google Sheets I'm using. So it's equal present value, and you can read there the present value of an annuity investment. That's what we're looking for. Open parenthesis, the rate. So we come up here and grab the required return, interest rate, whatever you want to call it. And then the payment amount, which is $100, and it's always the same because it's it's an annuity. And then the number of periods. Oh, I messed those up. I'm sorry. The number of periods is first, so the number of periods is 10. So I'm just going to hardwire that because we have 10 of them. And then the payment amount, which is 100. And if we want to, in this case, we can then close the parenthesis because it is an annuity, not an annuity due. I just want to show you, and I'm going to put a comma here so it comes up. If you have a future value that is, it's going to be worth some period in the future, we can put there. We don't in this case. Or if it's going to be at the beginning, so if it's an annuity due, instead of a 0 at the end, we would put a 1. But in our case, we have no future value to worry about, and it's an annuity, not annuity due, so we can hit enter. And the only other thing, when I hit enter, you'll see it comes out negative because they assume that you are making these payments out, so these would all have been negative cash flows. All we do is make a quick correction of that, and we'll put a negative sign there, and sure enough, the formula gets the same as the brute force method, so that was good. Let's look at it in future value terms as well. Here we have $100, and we put it aside at the end of each of 10 years, and we're going to have the same. I'm going to just copy this over so we have the same thing. Boom. Control copy. Bring it over. Okay, so here we have the same. And now I want to know how much will you have at the end of 10 years. So how much right here at the end, if we add all of this up, what we get. So this is an annuity. This is a future value annuity problem. But we're going to do it a different way. We're going to do it brute force first. And if we in fact, I will write this up here. So brute force. And here what we're going to do is this $100 will grow, and it will grow for how many years? So it's going to grow at 1 plus this required rate of return. And then the trick question is, how long is it going to grow for? let me try this again. It's going to grow, so we're multiplying. The 100 times 1 plus the growth rate, the required return, and then raised to, and this is going to be the exponent. Well, if it's at the end of 1 year to the end of 10 years, that's 9 years difference. So it's just going to be this number minus this number, and we go from there. So we close parenthesis and hit enter. And let's think about that for a second. $100 for 9 years, 155, let's just see if that's right, equals $100 times 1.05 raised to the ninth. And we close parenthesis, and sure enough, so we did our math right, that formula is right, etc. We do have to make a slight modification here. We have to have this. No, what do we have to do? We have to do G1. So we have to make sure the 1 is anchored down, and we have to anchor the F14 down as well, since that's always going to be 10 years out. So there we go, and we copy and nothing changes. But now what we can do, oh, whoop, sorry about that, went too far down. So what we can now do is copy this, and does it pass the common sense test? So they're getting smaller, which is right, because those $100 have less time to earn interest. That's good. The last year comes in at the end of year 10. So you pay out $100 at the end of year 10. And I asked the question, how much is it worth at the end of year 10? It's 100, so those two make sense. We add those up, equals sum, and we will get $1,257. I'm going to put this into $1,258 actually, but we'll put it into currency, and there we go, $1,257.79. Like before, there's a way to do this. If we want to, we can do it equals, already did that, equals future value and the rate, which is here, and the number of payments, which is here, and the cash flow that is there. And again, we don't need to do anything else because it is at the end of the period, not the beginning. So boom, and we already saw that it's going to come out negative, so we can just put in a negative sign right here. We don't have to worry about that. And boom, 1257.79. So very, very good, all useful. Now, that works really well if the cash flows are the same, and we can play nice games with this. We can say, all right, what happens if, let's go to present value first, if interest rates go up. And if interest rates go up, we're getting money in, but the money's not going to be worth as much in the future. So sure enough, that goes from 770 to 671. If interest rates go down, 0.05, and it goes back up. So that's an important thing. On the other hand, in the future value questions, if we earn a higher rate of return, that's what we're earning, it's going to be worth more. So if I put in here 0.08, we're going to go from 1257 to 1448. So it went up about $200. Okay, so final thing, what if their cash flows are different? And here I just wrote on my timeline, 100, 200, 400, etc. So it's not always the same. And we could brute force it. We could do the exact same thing we did before. We could go through and, equals this divided by 1 plus this, close parenthesis, raise it to the first, and there, and then we would copy this down after we anchored the K1, so anchor that in, and we can copy that all the way down, boom, 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 and hit enter, and then sum them up because they're all present value now, so this is brute force, and we add those up, and we get whatever we get. $2,394. So that's how we could do it. Or, mercifully, and this is probably the one Excel formula, one spreadsheet formula I use more than anything else, equals net present value, open parenthesis, get the required return, 6%, and then cover up the cash flows. Boom, 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 boom. And it assumes at the end of the period, so we get $2,394. again. So net present value is a very, very useful tool. We'll use it in pricing stocks and bonds and other things later. But you can always fall back. You can always brute force it if you don't remember them. But I highly recommend you remember net present value. So there you go. Thanks so much. And I hope this helped. And if I can figure out how to record it or how to stop recording, quick, there we go.